The following question reads, a showroom contains exactly 6 new cars, T, V, W, X, Y, and Z, each equipped with at least one of the following 3 options: power windows, leather interior, and sunroof. No car has any other options. The following conditions must apply. Okay, so we have exactly 6 new cars. T, V, W, X, Y, and Z. And we know that each car is going to be equipped with at least one of the following 3 options: P, L, and S. So we can place at least one spot next to each type of car because we know each is going to be equipped with at least one. And now we can go to the rules. Rule number 1 tells us that V has power windows and a sunroof. Okay, so we can just put that straight into our setup. V has power windows and V has a sunroof. Now, we don't yet know whether or not V also has a leather interior, so we're going to just leave that open. Because remember, we try and indicate in a setup like this if that's all that a variable has with a vertical mark like this, but we're not going to do that at this point quite yet because we know that V has P and S, we don't know whether or not V also has L. So, rule number 2, W has power windows and a leather interior. Again, we can put that straight into our setup: power windows, leather interior. Again, we don't know if that's all that W has, so we'll leave it open. Rule number 3, W and Y have no options in common. So we know that W does not have anything in common with Y. Now, what does W have? W has P and L. Y needs to have at least one of the options. So for W and Y to have nothing in common, Y is going to have the one feature that W doesn't have, which is S. And that means that's all that Y has. So we're going to place a vertical mark here. And that means that that is all that W has, because W cannot have the third feature, which is S, because W and Y have nothing in common. So now, rule number 4, X has more options than W. So we're saying that X has more options than W. Well, we know that W has 2 options. We made that inference based off of rule number 3 and rule number 2 together. So since W has 2 features and X has to have more, that means X has all 3 features. So we can place in P, L, and S for X. And even though it's redundant because there's no other feature it could have, we'll just close it off like this. Now, rule number 5. V and Z have exactly one option in common. So we know that V and Z equal exactly 1. All right, so what do we know about V and Z? We know that V must have P and S, and we know Z has to have exactly 1 in common with Z. So what that means is that Z can have at most 2 features. Z can't have 3 features, because if Z had all 3 features, then it would have P and S and L, making V and Z have exactly 2 in common. So here next to Z, we can just remind ourselves that it can't have all 3. And our last rule, rule number 6, T has fewer options than Z. Okay, so we have T fewer than Z. Okay, so we know that Z has at most 2. We made the deduction in 5 that Z can't have all 3. That means Z can have either 1 or 2. But if T has fewer options than Z, that means Z is going to have 2 and T is going to have 1. So we'll place one more here, and we'll close it off, and then we'll close off T as well. Now, going back to rule number 5, we know that V and Z have exactly 1 in common. So this means we can close off V at P and S, because if V had P, S, and L, then V and Z would have 2 in common. And we can place one of Z's spots for P or S, and then the other one for L. So that way, V and Z will only have one option in common, which will be either P or S. And lastly, the only thing we know about T is that T will only have one option, and so we can place our triple variables here, P, L, and S. So here we have all of our options filled out, taking the extra time and care to see how each of our rules relate to one another. And we have our setup, our rules, and our deductions. So let's go ahead and hit the questions.